Hello again from my screen. Now we're just going to revise a couple of stuff that we went over in our first session. If you all remember, we discussed different data types that we can use to initialize different variables. We talked about integers, which is int, float, double, which give us floating numbers and numbers with decimals. And we also talked about strings and characters. And we briefly discussed the Boolean, or like the bool data type. And we're gonna talk about them a little more today. And we also talked a little more about statements and else if and else. So we're gonna actually talk a lot more about these topics today. And if we have enough time, we're going to be also covering a really, really important topic, like a new important topic today. So also we talked about input and output, and we talked about how we can receive data from the user and how we can actually type out, or like see out, as we mentioned before. Like we can see out specific strings, we can see out absolutely anything. We can see out variables as well. But here's the thing, we didn't really talk about receiving strings from the user. So we talked about integers, we talked about floats and doubles, and characters as well. But we didn't talk about strings. So here's the thing about strings in C++. So I'm just going to start with declaring string name, for example. And I am going to prompt the user to enter their name. So please enter full. So I am going to ask the user to enter their name, and I'm just going to simply say cn name, since that's what we're used to. We just use the cn. We use the cin statement, and the arrows have to be greater than, which is different than cout, as we mentioned last time. And then we're going to actually test it out and cout name. So let's try it out and see. So as you can see here, I said, please enter full name, which means I might be entering 2 or more strings. And in order for you to enter your full name, you can't just have it compact all together. You have to have spaces in between your first name and your second name, or your first name and your initial, your middle initial and your last name. So I'm going to start with Farah Khanma, for example. So here's the thing, when we actually see out the string and when we receive the string from the user using cin, we do not get the second part, like we do not get the full entire name. And that's because with strings, when we have a break, or when we have or when we enter, or when we click the bar, the space bar, for example, it would completely disregard anything to the right and only take the first string entered. So in order for us to fix this problem, we are gonna completely forget about cin, and that's only for strings. So cin, what we're gonna be talking about now, is just gonna be valid for strings. We are gonna use a function called getLine. When it comes to getLine, all we have to do is type getLine, open up two C's, and write cin and the name of the variable, which we called name. And we're going to try it out. We're going to see out the name and see how it goes. I'm just going to enter my name again, my full name again, and see. So it's supposed to give us Farah Khanma. So that's why when it comes to strings, it's important to use getLine. And you can also, like, you can use, for example, name and last name. Like, you can do that and request the user to cin name and cin last name. But it's so much more efficient when you can just simply just use the getLine function and just type out the string and have the user just simply click enter whenever they're done. So I just wanted to mention that real fast, since I didn't mention it last time. And again, this is just for strings. Other data types like integers, doubles, floats, and even characters, we receive them from users the same way. We just use the cin statement. So I also wanted us to talk more about if statements, since we briefly discussed if statements last time. And I wanted us to introduce something new this time. So we talked about relational operators, or we also talked about relational operations, where we actually use, for example, greater than or equal, or less than or equal, or greater than or less than. And we also use equal, which is very different than assignments. So we use these relational operators to compare specific values or compare variables. We can compare integer variables, we can compare floating variables, and we can also compare characters as well. But what I also wanted to mention today would be the Boolean operators. Now, I mentioned the bool data type. I briefly mentioned it last time, but we're going to actually dig a little deeper with Boolean today. Now, when it comes to Boolean, or when it comes to the bool data type, we can only save true or false values in that variable. And Boolean operators actually also help us compare specific values, but they're a little different than relational operators. So when it comes to Boolean operators, we have and, we have or, and we also briefly talked about not last time. So basically, when it comes to and, or, and not, we use these also, as I mentioned, to compare. So when it comes to and, and is symbolized as two and symbols over here. And with or, it is just two straight lines. And with not, it's just simply an exclamation mark, sorry. And we talked about that last time, but we're gonna actually talk about them a little more today. So when it comes to and, I'm just going to give a brief example. So for example, we have two integers. We have integer x and we have integer y. So we're going to give integer x a value of 5, for example, and then we're going to give integer y a value of 7. So I want to write a program that, let's say, executes a certain instruction if x equals 5 and if y equals 7. So we use if statement, we use one if statement, and we simply say if x equals 5, and if your equals is different than equals, since here we are comparing and not assigning, and y equals 7, we wanted to print have a great day. It's just a very, very random example. So this is the simplest example to how we can use Boolean operators. So in order for us to execute this specific, both these conditions need to be true. So in order for us to print have a great day, x has to be 5 and y has to be 7. So let's give it a shot and test our code. So it's supposed to print have a great day since both x equals 5 and y equals 7. However, if x equals 8, for example, if we change it up and switch things up and compare y to 8, the program is not supposed to be printing have a great day. So there you have it. The program is not going to print this specific instruction if one of these conditions is not true. So when it comes to and, both these conditions have to be true in order for us to print whatever it is inside the if statement. However, if we switch things up and go with or, let's see what the program gives us. So y is 7 here. It is not 8. However, x is 5. So we're going to see what the program gives us and how the program executes. It tells us have a great day. So when it comes to or, at least one of the conditions has to be true in order for us to print out the instructions, or in order for us to actually enter the if statement and continue on and print out the instructions that are inside the if statement. So this is what's different between and, or, and we talked about not last time, but I'm gonna give another example today. So a quick revision, and if we're using and, both instructions have to be true. If one of them is false, then we will not be executing what's inside. However, when it comes to or, at least one of these conditions has to be true in order for us to execute whatever is inside the if statement. So I'm going to actually give a different example. And I'm going to use Boolean operators this time. I'm going to actually use Boolean data types this time. So I am going to go with bool is old, for example. And as we mentioned, with the bool data type, we can only give true or false values. So for now, I'm going to give a true value to the variable is old. And I'm going to include an if statement and simply just write is old, open two curly brackets. Now here, when we just simply write is old, and since is old is a Boolean data type, we are using bool here. This means that if is old is true, then we get to execute whatever instructions we have inside the if statement. So just to test it out, I'm going to say if is old is true, then cout you are old. This is just a simple example. So we can also say if is old equals true, but we can just simply, it's just a shortcut if we just include the variable. So I am gonna run the code and see how it goes and see what the compiler gives us. So it's gonna print you are old since is old is actually true. Now I'm gonna add an else instruction, an else statement, and include a cout statement saying you are young. I'm actually gonna keep you are old over here, and I'm gonna keep is old equals true. I'm gonna switch is old, and I'm gonna switch it to false and see what the compiler gives us. So there you have it. It's going to print you are young. Now, when it comes to Boolean operators, a Boolean data type, we can actually incorporate the Boolean operators when also working with the bool data types. So for example, I'm going to add another bool variable, and I'm going to name it is female, for example. And for now, I'm going to give it the value of true. So I'm going to add another condition in the first if statement and say if it's old, which is here, if is old equals true, and is female, which here means if is old is true and is female is true, print you are an old female, for example. Else you are, we're just going to keep this for now and talk about it later. So here we all I simply did is add another Boolean variable, and I called it is female, and I gave it the value of true. And I want to see what it's going to print, what the program is going to print when we execute. So interesting. Oh, there we go. So can anyone tell me why it printed you are young?
Because it's never going to, apply the first statement, because it's like true and false is true.
So true and false, since we use and here, if you have true and false, it's going to be false, right?
Yes, because both conditions must be true, but now we
Absolutely.
have one true and one false, so it's never going to execute.
Exactly, 100%. However, if we try to alter is old and give it a true value and run our code, and we'll see what the compiler will give us. And it gave us you are an old female. And that's because is old and is female is true now. I'm going to actually try and add another condition. So I'm going to use an if statement and say if else if not is old. So if is old equals false or opposite to what we have here, and is female. I'm going to keep is female as true. I am going to see out you are a young. So let's give it a shot. So basically this translates to if you are not old, but you are a female, then we will execute this specific instruction, which is a CL statement saying you are a young female. So I'm going to switch things up and change is old to false and keep is female as true and see what the compiler gives us. So it prints you are a young female. And that's because we changed is old into a false value. We gave it a false value and we kept is female as true. However, if we change and here and include an or Boolean operator, let's see what the code gives us. So with or, we said that at least one has to be true. So is female is true. And it is old. It didn't really give any attention to is old. So it printed the same exact thing. However, if we kept and here, so I think I'm confusing you right now. I'm using way too many ands and way too many ors, and there are so many different else statements and if statements, but here we're simply just scratching the surface. Like there are so many different examples, so many different combinations, but what I want to try to get across is the fact that and, when it comes to and, both conditions have to be true in order for us to execute the code. However, when it comes to or, at least one has to be true in order for us to execute the code. So that's basically what it is. And also one more thing that I didn't really mention last time when we discussed if statements. So I mentioned that we can use if and else. And here's why I usually prefer we use else if instead of if, and else. Because if we actually removed else over here and we kept if and if, the code or the compiler will go through all of these if statements, even if the first one just did the job. So when we have else if, the compiler does not have to go through all the different statements if we already achieved what we wanted to achieve before this statement, for example, or before the else statement. So that's why I usually prefer if we have two or more conditions or we have two or more combinations, we can use else if instead of constantly using if and if just for the sake of being efficient. And as a programmer, efficiency is definitely one of the key factors that you need to consider. So this is just a very, very simple example. We're just scratching the surface here. We just used a Boolean data type. We declared two Boolean variables, and we tested out the Boolean operators in this example. But what I want us to actually get into today is different comparisons that we can use. So before we talk about that and before we cover that and talk about different examples, I want to introduce something else to you girls. And this is and what I'm going to introduce is called the assignment operators. Now, the assignment operators are very, very simple, and we actually talked about them before. So we talked about the difference between comparing and assigning. So for example, when we're assigning a specific value to a variable, we do not use equal equal, we only use equal, right? Because it's different. We're not comparing anything to anything. We are assigning a specific value to a variable. However, we can also use so many different assignment operators, and we will actually be using them later on when we are introduced to different functions and different statements that we can use that would help us with more difficult computational problems. And we can also use, for example, plus equal, and minus equal, and multiplication equal, and division equal. So we can use so many different assignment operators. So for example, plus equal is basically the same as, for example, we declared integer num1. Okay, I'm gonna actually remove this, and we're gonna give integer num1 initial value of 8, and I want to add 4 to the value of 8. So we can simply say num1 equals num1 plus 4, but simply to like, we use the assignment operators as the shortcut, and all we can use is num1 plus equals 4, which would basically give us the same exact value. It's just a shortcut. It's just a lot simpler. So we can also use multiplication. We can use multiplication over here. It's the same exact thing. We can use division. We can also use modulus as well. So I wanted to mention this real fast because we are going to be talking about new topics where assignment operators would actually ease the process and make it a lot more convenient to us as programmers. And if you girls actually check the questions that I attached post our last session, I asked, one of the questions was to find the greatest number between two integer values. So I wanted us to basically ask the user to enter two specific or like two different integer values and have the program print out the greatest number. However, what if we wanted to switch things up and ask the user to enter 3 integer values and print the greatest number out of the 3? So I want you girls to help me. So when it comes to this specific computational problem, we are going to be using relational operators and Boolean operators, as well as, of course, if statements. So we talked about all of them now, and we revised all of them now. So what do you think would be the first step? Any volunteers?
Choosing the values.
So we have to ask the user for the values, right? So we're gonna declare 3 different integer values, or like 3 different integers, variables. And we are gonna ask the user, prompt the user to enter 3 integer values, right?
Yeah.
So that's basically the first step. And here's the trick about cin. You can simply do the same thing when it comes to cout and just enter all the and like actually type out all the variables at once, since they're the same. Since we're just gonna ask for them at once instead of having cin num2, cin num3. So it's just more convenient. Anyway, so what would be the next step? So we just received the values from the user. We asked and we received. So how will we actually solve this computational problem now? I'm going to help you with the first step and just type out an if statement. So what are we going to be writing here? Any volunteers? We're comparing these 3 integers. So the first step would be to check if number 1, which is the first variable we entered, is greater than num2 and greater than num3. So I just gave you the hint. It's going to help you solve the problem. Num1 is greater than or equal to num2. And I want you guys to help me here. You can do it.
I guess we can write and number 1 is also greater than number 3.
Absolutely. So we're going to go with greater than or equal just to ease the process. 100%. So if both these statements are true, this means that num1 greater than or like the greatest number out of all the 3 numbers. So what are we supposed to see out here? Since
num1 is the greatest number.
Is the greatest number, absolutely. Is the greatest number. So what about the rest? What about the rest of the numbers? What if num1 is not the greatest number?
We can simply write else if num2 is greater or equal to num1.
Mm-hmm.
Or we can just understand how it works and what the conditions are left, and we can just use else instead of keeping writing.
Yeah. So here's the thing. When it comes to the three numbers, there are three. So basically, there are three combinations. So it's either num1 is the greatest number, or num2 is the greatest number, or num3 is the greatest number. So this else if statement is needed, but when it comes to the last state, since, for example, if num3 ended up being the greatest number, we do not need to include another else if, since basically there's no other greater number than num3. So for now, we're just going to keep this else if statement if num2 ended up actually being the greatest number. But when it comes to the last statement, so here we are going to print out num2 is the greatest number. But since we actually included if statements for both num1 and num2, there's nothing else left, and we can just simply say else see out num3 is the greatest number. Is it clear, or does anyone have any questions?
I have a question.
Yes, go for it.
When do you choose to like put the end, like in the second else if there's no end at the end of the statement? You just put the semicolon.
Oh yeah, it's fine. You can. Oh, you're talking about line 24. Are we talking about this line?
Yeah.
Yeah, it's my bad. I completely forgot about add line. We can just simply include it at every line just to avoid confusion. So it's fine. You can include and L. It's not mandatory to include end line. And L basically stands for end line. But just for the sake of organization, we can include end L. So all we did here is simply compare between two numbers. We use the relational operators to compare num1 and num2 and num3. And we use else if statements, if and else if and else to basically determine which number is the greatest number. So this is, again, a very, very, very simple example, since I asked you girls to find the greatest number between two numbers, but when we have another number involved, it gets a little difficult. So this is where we have to use Boolean operators as well. So does anyone have any questions regarding anything we just discussed? Please feel free to ask anything before we move on. Okay, awesome. So I wanted to introduce you to the ASCII table. Now I'm going to remove that, or actually I'm going to keep it. And I am going to duplicate our compiler over here and give you another example that you're going to help me solve. So an ASCII table basically contains all the different symbols we have on our keyboard right now. And each and every symbol actually has a decimal value. So for example, we have an uppercase A. It has the decimal value of 65. And uppercase B has a value of 66, and so on and so forth, until we get to Z, which has a value of 90. And also when it comes to, for example, lowercase letters actually have greater decimal values than uppercase letters. So I wanted to show you this table because we are going to be using it also later on when we talk about arrays and when we dig deeper into strings and when we solve problems. So I want you to currently, and I want to give you a very, very simple example and see if we can actually figure it out together. So I just give you a hint, and basically each and every character on our keyboard actually has a decimal value, which means that A is less than B and C is greater than B. So I want us to ask the user to actually input a specific character, and I want us to write a program that determines whether this character is an alphabet, is an actually a letter in the alphabet or not. So I'm going to help you out, and I'm going to start with the first step. So I'm going to say, I'm going to declare a new character variable. I'm going to call it alph, for example, or test. Let's just go with test. And I'm going to prompt the user to enter a character. And all we have to do is cn test. So I'm going to give you another hint. So in order for us to determine whether this character is a letter in the alphabet or not, we're obviously going to be using an if statement. So in the ASCII table, each and every character has a specific value. So what do you think we should include in the if statement, since we can, as I mentioned before, we can compare integer values, floating values, and even characters. So how can we write a code that helps us determine whether this is a letter in the alphabet or not? I'm going to help you with the first step. I'm just going to write A. Oh, sorry. I'm going to write test greater than or equal to A. I want you to help me with the rest, since we are comparing characters. What do you think?
And test is less than Z, I guess.
Absolutely. Great. So less than or equal, right? So since it can be from A up to Z, and can be A or Z. So this is great. This is a great step. What about lowercase letters? Because a user can enter in an upper or lowercase letter. So what do you think?
Or
I'm going to help you the first. Yes. I don't even need to help you. You girls can get it so easily. Or,
test is greater than or equal small case A.
Yeah.
Yes. And then what do we have to include?
And test is less than or equal to
lower.
small case Z.
Absolutely. You girls are amazing. Absolutely. So what do we tell the user if these conditions ended or like turned out to be true? See out.
No, it's a part of the alphabet.
Exactly. So test is, for example, a letter in the alphabet. So what if it actually wasn't a letter in the alphabet? You have to tell the user something, right?
Yeah, we put else if.
We can say else if, but since it's either alphabet or no alphabet, we can just use else, right? It just makes it easier. But we can simply say else if test does not equal A. It's just a very, very long way, since it's either an alphabet or not. So we can just simply say else, right? Open curly brackets and see out. What's the message we should actually tell the user? What should we tell the user?
Test is not a letter in the alphabet.
Is not a letter in the alphabet. So here's the thing. This is 100% true, and this is 100% right. But I personally always prefer to isolate all these conditions in parentheses, just so we can make sure that we will be getting the correct results. But they're all going to be working out just fine. But I personally always prefer, and this is actually a very important thing that each and every programmer should be doing. And it's always to isolate these specific conditions, just so everything is clear and just so we avoid any misunderstandings or avoid any errors. So let's give it a shot and let's run and execute our code and try to enter an exclamation mark, for example, and see what the code gives us. There you have it. So this character is not a letter in the alphabet. And if we try to enter H, for example, let's try and enter H. H is a letter in the alphabet. So perfect. Our code is working and everything's going great. So I hope these examples actually help you or like help us all together solidify the solidify everything we're taking. I hope they're actually helping you understand the Boolean operators, if statements, else if, and else statements a little better. Because now we are going to move on to something a little different. It's very, very, very simple, and it's very similar actually to if statements, but it completely it really eases the process for us as programmers. And I'm going to introduce you to something new called switch statements. So switch statements are actually an alternative to if statements. But all they basically do is tabulate the information and make it a lot easier and clearer. So I'm just going to give you a very, very random example. I'm going to ask the user, we're going to write a program together where we ask the user to see in a specific number. We're going to call it integer n, for example. And we're going to see out, we're going to prompt the user to enter a specific number. So we are going to ask the user to enter a number. According to that number, we are going to print out a day of the week. So for example, if the user enters 1, for example, we are going to print out Sunday. And if the user enters 2, we are going to print out Monday, and 3 Tuesday, and 4 Wednesday, and so on. So we can use multiple if statements, we can use multiple else if statements, but switch statements actually really help us tabulate all this information through cases. So in C++, all we have to do is add switch, and we are going to write the name of the variable we are comparing, or the name of the variable that we are checking cases for. So since the variable here is n, we are going to write in between the parentheses n and open two curly brackets and start our code. So we are going to have various different cases. So we're going to start from 1 through 7, and we are going to start with the first case, which is case 1. So in case 1, if the user enters n as 1, we are going to see out Sunday, for example. But here's the thing with switch cases. Now, when it comes to switch, we always have to include break. So break basically stops the code there. So I do not, in this specific project, we do not want the code to print out Sunday, Monday, Tuesday, Wednesday, for example. We just wanted to print one day of the week because we're going to have more than one case. So if we have case 2, which we are going to see out as Monday, we are going to want it to stop there. So that's why we have to use break after each and every case. And we're going to be talking about break also later on when we discuss loops, for loops and while loops. But for now, we are going to include 7 cases, and we are going to print out a day of the week according to these cases. So we are going to include Tuesday, and 4 is Wednesday. 5. I'm just going to include them all at once. 5, 6, and 7. And we're going to say Tuesday, Wednesday, Thursday, Friday, and Saturday. Friday and Saturday. So this is just a very, very simple example for switch statements. So again, we have these cases, and case 1 is if the user ended up entering 1, and where we'd print Sunday. And for example, if the user ended up printing 4, the program will be printing Wednesday. And we include all these break statements in order for to print any other statements, or in order for the program, let's say, to just completely exit the switch statement after printing what we are asking it to do. So here's the thing also with switch statements. For example, if the user ended up entering 10, now there are 7 days in the week. There are no 10 days in the week. There's no 10th day in the week. So we have to include a default statement that, in this case, would print out, for example, invalid day, right? When it comes to the default, we can include break, we cannot include break, it doesn't matter, because the switch statement is only gonna refer to the default statement if the user did not enter any number from 1 through 7. So simply, switch statements are an alternative to if statements. You can totally like disregard to if switch statements and switch all these cases with if statements, but switch actually helps us, as I mentioned, tabulate all this information and make it a lot more convenient through these cases. So let's give our code a shot, and let's actually try and execute the code and enter 5, for example. So it is going to prompt the user to enter a number, and we are going to enter 5. Just wait for the program to work. And there you have it. It prints Thursday. So let's, for example, remove break and see what it would give us. We're going to enter 5 again, but without the break statement over here. It's going to print Thursday, Friday. All right, so this is why break statements are important, in this case at least, because sometimes you might actually need to print more than one statement, or you might want to print 2 different cases. So it's all up to the programmer. But in this case, and in this mini project, we just want to print 1 day. We just want to print 1 day of the week according to the cases. So let's try the default statement. Let's try to enter 19, for example. They're obviously not 19 days a week, so it is gonna go ahead and execute a default statement. So here's the thing. I want us to actually create a better calculator. So I remember in our first session, we created a calculator that we created a program, that would prompt the user to enter 2 numbers, and we'd print out all these different operations. We'd print out the sum of the 2 numbers, we'd subtract the 2 numbers, we'd multiply, divide, and even when we had integer values, we would use the mod operator. However, I want us to use the switch statement now to ask the user to enter 2 numbers and enter a character. And according to the character, we would execute a specific instruction. So I'm going to remove the switch statement, and we're going to write one together. And I'm going to start with the first step. So I'm going to ask the user and prompt the user to enter the first number and have n num1, for example, and num2. And we'd have the user enter num1 and then enter num2. And also going to declare a character variable, and we're going to call it OP, short for operation, for example, and prompt the user to enter a character. So the character, as we mentioned, can be plus sign, minus sign, division, multiplication, or mod. And we can use mod here since we have the numbers as integers. When it comes to floats and doubles, we cannot use the mod operator. And we receive the character, which is the OP. And I want us for now to use switch statements. I do not want us to use if statements. So what do you think would be my first step? Any volunteers?
Switch n, and we open brackets.
N?
num1.
Are you sure? So we are defining cases for the character. So according to the character, we
So char.
so what do we include here? What's the
Char.
variable? Char. So it is a character, but we have to include the name of the variable.
Okay, operator, I'm sorry. OP.
Yeah, perfect, absolutely. So it's OP, which is short for operator. So here we are gonna construct, or like we are gonna define specific cases. So for example, for the first case, if the user entered plus, we are gonna want to execute something. So there's one thing we missed. Now we have to store the variable, we have to store the result in a variable. So what do you think we should add? There's just one small thing that we need to add, and I just gave it away. We have to store the result in a variable. So what do you think? We need to do one small thing, one extra step.
We need to declare an integer or a float.
Integer?
Yeah, and a result.
Yeah, absolutely. Perfect. So all we have to do is follow these cases, and according to these cases, create or execute specific instructions that would then give us the result. So in the case that OP was plus, what do we have to tell the program to do in this case?
num1 plus num2.
Okay, but we need to store it somewhere, right? We need to store the result somewhere. We have to use the variable in line 17, right?
Result equal
Mhm.
num1 plus num2.
Absolutely. So result equals num1 plus num2. And
And
since
then-
we,
Yeah, I just wanted to say we print the result.
so we print the result, we can simply see out result. We can absolutely do that. But here's the thing, if we see out the result here, that means we have to see out the result at every single case, right?
Shouldn't we put break at the end?
We
Or this is
definitely
just an
should.
idea? Oh, okay.
So here it actually does apply here, since if we forget break, we are going to get invalid results. So we do need break here. And also it's totally fine to include the see out statement in each and every case. But as I mentioned, we also want to be efficient. So we are going to keep the results. We're going to see out the result. We're just going to wait on it for now. And we're going to talk about see outing it later. See outing it. I like that term. So for now, we are just going to give the value to the result according to the operation, according to specific cases, and break. So as I mentioned, we have different cases. So we have plus, minus, multiplication, division, and modulus. So what do you think we should do now?
Case and then the minus sign in between quotations.
Absolutely. And all we have to do is simply copy and just replace it with minus. And we do that with every single case. So all we have to do is include the asterisk here, result, multiplication, and break. We don't forget break because we want to avoid error values. Oh, sorry, we include the case. One last thing. Also, can someone tell me why we are not using double quotations?
Because OP is a char.
Absolutely, exactly. And what did we say about characters?
We use one quotations.
Exactly. So that's all we have to do, and we copy and paste. It takes a little bit of time, but this calculator, you can't deny that this calculator is way cooler than the one we had before, since we give the user the chance to actually choose the operation they want to go for instead of printing everything all at once. So what if the user again enters an invalid operator, or like what if the user enters an as, for example, or default. Absolutely. And all we have to do is just see out invalid operator, for example. You girls are doing great. But there's just one more thing. So we talked about see out result here. But when we see out result here, we're going to have to see out the statement. We're going to have to copy paste the statement in each and every case, right? Which we mentioned is not efficient whatsoever. So where exactly do we see out the statement? Where do we print out the result?
After the whole switch statement.
Absolutely.
Because only one case is going to be executed. Only one case is true.
100%. Absolutely. So all we have to do here is see out. The result is result. Awesome. So this is great. So just to revise the whole entire thing, we used a switch statement. We, of course, first asked the user. We prompted the user to enter 2 integer numbers. And then we prompted the user to enter a character, which we declared as OP. And we stored the value in the result according to specific cases that follow the character OP over here. So, is everything clear? Should we try and execute our code and see how it goes? Let's try and see. Let's try and run our code. So enter the first number. I am going to enter 7, for example. Oh, I just remembered that we forgot to enter the second number. But it's fine, we can just fix it now. We just forgot to prompt the user, but it's waiting for us to enter num2. So I'm gonna enter 8. And we are gonna go with multiplication. And there you have it, the result is 56. So the thing I did here is that I included num1 and num2 in the same statement. We can just simply say enter 2 integer numbers or 2 integer values. Or you can actually prompt the user to enter num1 and then prompt the user again to enter num2. So that's basically it. So all the switch statements actually did is simply, instead of having numerous if statements, we just have one switch statement with various cases inside. You can definitely use if statements. You can definitely use else if and else. It's all valid. This is just more convenient. So let's try and enter an invalid character and see what the switch statement gives us. So I'm going to enter the 2 numbers. We're going to enter 5 and 2, for example. And then we're going to enter at. Invalid operator. But it still gave us a result because it's outside, which is totally fine. We can fix it. We're going to learn a lot of stuff that would help us fix it. But for now, this is how our program works, and it's looking great. So we talked about switch statements, we talked about if statements, and now it's time to introduce something new. Now I think we have enough time. We have around 30 minutes. So we're going to talk about it briefly. And maybe next time we can actually solve some problems that would help us understand what we're going to be learning now a little better. So we are going to introduce the for loops. Now, I really, really like for loops because they ease the process for the programmer, and they're very, very, very important and very, very useful. Because sometimes, for example, if I wanted to execute or if I wanted to write a program that prints numbers from 1 through 10, it's not going to be very efficient to use cout statements 10 times. Because what if I wanted the program to print numbers from 1 through 1000? You cannot, I mean, you can if you have the patience for it, but it's just going to be very, very inefficient for you to cout the statement 1,000 times and alter whatever you have to write 1,000 times. So this is why we use loops. So for now, we're going to be talking about for loops, and we will be discussing another type of loops later on throughout the course. So what we have to know about for loops is that a for loop includes 3 components. All right. We need, in order for us to write a for loop, we obviously need to write for, and we open 2 parentheses, and we start with formulating our for loop. So the first thing we need to include in our for loop is an index variable. So for now, I'm going to declare an index variable called integer I, and I'm going to give it an initial value of 1, for example. Okay, so basically an index variable declares where the for loop is gonna start at, and what's coming next, which we separate with a semicolon, would be the range, would be where our for loop is gonna stop. So for example, here I'm gonna be using a for loop that prints out numbers from 1 through 10. So I want this for loop to write to see out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want it to start at 1 and end at 10. So all I have to do is set the range for the index variable I and say I is less than or equal to 10. And then with another semicolon, and the last component of the for loop is the increment or the decrement, however the programmer wants it to go. In this case, we want it to print in an ascending order. So we want it to print from 1 to 10. So we are going to increment the index variable every time the loop works. So the first turn of the loop will print 1. Second turn of the loop will print 2, and the third turn of the loop will print 3, and so on and so forth until we get to number 10. All right. So here we are incrementing the index variable. So I am going to use I++. Now in C++, plus basically means adding 1 to the variable, and minus means decreasing 1 from the variable. But for now, we are going to be using plus, and I'm going to include 2 curly brackets over here. So as I mentioned, this for loop has a very, very, very simple job. All it's going to have to do is print the values from 1 to 10. So I'm going to see if any of you can help me. I'm going to try with the first step. So I'm going to start with the cout statement. And I want us to print something. So we're printing numbers from 1 to 10. What do you think something over here should be? I'm going to end the line after each execution. There's something that we have to include here. Does anyone have any ideas? So we're printing numbers from 1 to 10. All we have to do here, absolutely, yes, 100%. We have to print I because we are increasing I after every time the loop functions. So for example, in the first turn, we are going to be printing 1 since we set that as an initial value. And the second turn is going to be, we are incrementing I by 1 every time, and so on and so forth until we get to 10. All right, so let's give it a shot. So all we did here is set our first for loop. We set the initial value, we set the range, and we set the increment. So let's run our code and see what the code gives us. There you go. So it's going to print numbers from 1 through 10. So what if I altered a couple of stuff here and I remove the equal here? What do you think the code would give us?
From 1 to 9.
Absolutely, yes. So it's going to give us numbers from 1 to 9. So let's ask a question that's a little more difficult. What if I wanted the for loop to print even numbers from 1 to 10? So I'm going to include, let's just test it out and see what the code gives us. It's going to give us numbers from 1 to 9. And that's because we removed the equal here. So the range is going to be less than 10. So back to the question, what if I wanted our for loop give us numbers, even numbers from 1 through 10? So what did we say about even numbers and odd
We
numbers?
We use an if statement.
So if, and then, what do you think?
I modulo 2 equal
Equals 0.
okay. Count, see out.
Yes.
Okay. Oh.
So see out. So here's the thing. I think I wasn't that clear. I just want, for now, I just want our for loop to print even numbers only. So
See out I. See out
outside.
I.
So
Yeah.
exactly. So if I modulo 2, which we said would give us the remainder, equals 0. So if the remainder is 0, that means the number is even. And what about odd numbers from 1 through 10? Just one simple thing.
We can just say else.
Else, okay.
See out I.
Sure, yeah. We can try that, absolutely. So hi is a string. And we can give it a shot. So let's see. Let's try it out. There you go. So it's printing hi if the number is odd, since here we are checking if the number is even. And it's printing I if I is even. So hi 2, hi 4, hi 6, hi 8, and hi 10. So I want to ask a tricky question. What if I wanted to print the even numbers only without using if statements or else statements? It's a tricky question, but you guys can do it. I have to alter something here. Something in the code, something here.
Or can we do 2i?
So you're on the right track. You're definitely on the right track. So I'm going to give you a hint. So do you remember when we talked about the assignment operators and how, for example, int num1, I'm just giving an example, int num1 equals 4, for example, and I wanted to add 3 to 4, we can say num1 plus equals 3. You remember when we talked about the assignment operators? We can actually use this here. So I just gave it away. I think you can get it. It's something with the increment. What do you think? Come on, girls, you can get it. So I want us to print. Yeah, tell me, let me know.
Yeah. Okay, can we start in I equal to 0?
So you want it to start from 0?
Yeah, and then I plus 2.
I plus
2.
right?
Yeah.
Or we can actually just say I equals I plus 2, right? Sorry, 2. We can say that. So that's great. So we are starting from 0 and we're going where we're repeating the for loop up to 10. So instead of using if statements, what are we going to be doing now?
We just print I. See out I.
So let's give it a shot. There you have it. Absolutely brilliant. So what about, what if I wanted to print odd numbers? What do you think?
We just add 1.
We add 1.
We can start from 1 and add 2.
Absolutely perfect. So we can do that. So let's give it a shot. Let's see. It's supposed to give us the odd numbers from 1 to 10. Perfect. There you have it. Awesome. So I think we're on a great track. You girls are doing so well. And I want us to try something else. I want us to go a little harder. What if I wanted to, so I wanted to ask the user, all right, to enter a number. Okay, so I want the user to enter an integer value, and I want the for loop to print 1 times 1, 2 times 2, 3 times 2 up to that number. So for example, if the user, so I'm going to declare variable n, and I'm going to ask the user to enter n, enter integer value or number or whatever you want it to be, and see an n. So for example, if the user entered 5, I want the for loop to print 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, and up to 5 times 5, which is equal to 25. So this is a little more difficult, but I think you can do it. So we're just simply asking the user to enter an integer value, and we're going to be multiplying up to that value. We're going to be starting from 1. So I gave you the first hint. I'm going to remove that. What do you think our next step is going to be? We need to set the range. That's another hint. So we need to set the range. And the range over here is less than or equal to 10.
It should be n.
Yep. And what should we, how should we set the increment?
Plus plus.
Absolutely. And what about the cout statement? What do you think?
Cout I times I.
I times I? Sure, we can do that. Yeah.
Yeah.
So I want us to print, for example, I, which is on the right track, and I want us to print times something, which is I. And I want us to print the result. So how do we do that? I just added extra steps for no reason, but that was very valid. What do we write over here? So we're multiplying I by I, right? It's just a simple arithmetic operation.
Don't we write I times I?
Absolutely. That's all we have to do. And we end the line. So let's give it a shot. So here we started our for loop from 1. We're going to end it at n, which is something the user controls. And all we're incrementing I by 1 until we reach n. So we're going to start with 6, for example. Let's see what it gives us. Oh, I forgot the equal, but that's how it is basically. It's going to give us 1 times 1, which is where the I starts, and then 2 times 2, 3 times 3, 4 times 4, up to 6. So I forgot the equal, and that's totally my bad. And that's all we have to do. Let's start. Let's go with another number. Let's try 10, for example. Let's go with a bigger number. There you have it. And we go up to 10. So this is, I'm going to ask you another tricky question. What if we wanted to reverse the order? So what if I wanted to start from 10 and end at 1? What do you think I should alter in the for loop over here?
We put end I equal to 10, and then we decrement I minus minus.
Okay, so equal to 10? Is it always going to be 10?
No, equal to n, I mean.
Oh, okay.
Okay.
And I minus minus, right?
Yeah, and the length I is greater than or equal to 1 or 0.
So we're going to go with 1. Excellent. You can go with 0. You can go with... That's absolutely excellent. So all we did here is simply reverse the order. So we started from n, which we entered here as 10. And we will end the for loop at 1. But you should never forget the increment or decrement. Since here we are decreasing the value of I till we reach 1. So we're starting from n And we are decreasing the index variable, which we called I, until we reach 1. So let's give it a shot. Let's give it a shot with, let's try 7, for example. Let's try 7 and see how it goes. There you have it. So we simply just reversed it. All we did is set the initial value differently. So we set it to start from n, and we set the range to reach until 1. But you should never forget the decrement or the increment. And in this case, we are going to be decrementing. So are you ready to start? Are you ready to start solving computational problems? We are going to go with a problem that is on a program or like on a website called Codeforces. Now, Codeforces, I definitely recommend all of you actually create accounts on Codeforces. I'm going to be sending you an email. I'm going to be including all the steps to creating Codeforces, creating a Codeforces account. There's so many different examples on Codeforces that can help you practice programming. Some are hard. I'm going to keep on including these questions just so you can practice post sessions, you know? So we are going to start with our first Codeforces example. And for Codeforces, I even remember someone on the group, if you are on the WhatsApp group, someone mentioned something about the ID1 compiler, which we will be using as well. I want us to try to use different compilers. And I mentioned that the ID1 compiler actually helps us with the input. So when we use GDB, for example, every time we run the code, we have to enter the input all over again. So with ID1, which we will be using right now, we can just simply enter the input once and run the code as many times as possible and as many times as we want without having to enter the input all over again. So we are gonna try and solve the first Codeforces question together, which is called hamburgers. So we're gonna read it together. Mustafa likes hamburgers a lot, so he wants to buy as much hamburgers as he can. But sadly, his fridge can only hold up to 100 sandwiches. For his birthday, his friends bought for him N Krabby Patty hamburgers from Krusty Krab. Can you tell him if he can put all the hamburgers in the fridge? So here's the thing with Codeforces. The question always includes the input and always includes the output. So we just discussed for loops, so this question should be easy for us. So the input will include the number or like the single integer t. It doesn't necessarily need to be t, but this is just a general idea, which is here in the first test case is 3. And then we are going to include the number of hamburgers Mustafa's friends bought for him. So here they set the range and they tell us that his fridge can only hold up to 100 sandwiches. So as you can see here, we have 3 test cases. The first one is 50, the second one is 1,234, and the last one is 100. And the output is yes, no, yes. So why do you think it says yes for 50 and no for 1,234 and yes for 100? Why do you think the output looks like that?
Because 50 is less than 100 and 100 is equal to 100, while 1,234 is greater than 100. And 100 is how much his fridge can hold.
Absolutely, exactly. So it's as simple as that. All we have to do is check all the test cases and print yes if there are 100 sandwiches or less, and print no if the number of sandwiches is greater than 100. So should we start writing the code?
How come there's only 3 outputs but 4 inputs?
Oh, that's a very good question. So this is a great question because we're going to be using it now. Now, 3 is basically the number of test cases we're supposed to check for. So this is going to help us with the range of the for loop. All right, so this isn't really a test case. This is basically the range. This is the number of test cases we should test for. All right, does that make sense? Did I answer your question?
Yes.
Awesome. So I want you girls, I'm going to give you 30 seconds until I put my laptop in the charger, and I want you to think of ways we can solve this on the compiler. So I'm going to give you 30 seconds. So what do you think? Should we start coding? Let's start writing our code. So there are two types of variables that we need to declare right now. The first one is going to be the range, which is basically the number of test cases we're going to be testing. And the second one is the actual test cases. So we're going to start with the first one. So I'm going to say integer n and have the user enter n. So what do you think would be our next step? What do you think?
We need to write the for statement.
So I didn't hear that properly. What should we be writing? Should we start with the for loop? I'm going to start with the for loop, but I want you guys to help me write what's inside the for loop. What do you think we should be writing inside? I want new voices. Yeah.
I just wanted to say that someone before me said that you need to prompt the user.
So yeah, you can prompt the user over here. I always prefer to prompt the user since we always want it to be clear, but it's not very necessary. However, we absolutely can. We can just say cout enter n, and that's totally fine. You can prompt the user, you can just enter n. Since here in the test case, they just they didn't request the programmers or like whoever solving the question to prompt the user. They just asked us to enter the number, but that's totally fine. You can do that as well. Absolutely. I personally always prefer actually prompting the user, but for now, we're just going to follow what they're asking, which is over here. We're just going to follow the input over here, which only asks us to set the range. So I'm going to comment this out, or actually I'm going to remove it, although that's totally fine, and I actually even prefer it. So what do you think we should be doing now? I'm going to give you a hint. So we're going to actually name another variable and call it test, for example. And I want you guys to help me with the for. So test is going to be the test cases. However, how do we set the for loop? And I want to hear different voices. I want to hear new voices. So what did we say the first loop, the first step is? Yeah. So our first step is to declare the index variable, right? Right. So we're going to declare, we're going to give our initial variable or like the index variable an initial value of 1. And of course, we need a semicolon to separate all the components of the for loop. An indentation is not mandatory. I just want the for loop to be very clear. So I add these indentations and then we set the range. But are we the ones that set the range or the user is the one that sets the range? Any volunteers?
I is less than or equal to n.
Absolutely. And then we're just going to increment plus plus. So here's the hard part. So we set the range, which is actually given by the user. And we started from 1 and we go up to the range and we increment accordingly. However, how are we supposed to be getting the test cases? So this is the range, right? And we used it in the for loop. How are we going to be getting these test cases? The for loop is going to repeat 3 times. How do we get these values?
Cn greater than n. Yeah.
Yeah. So what is the variable we actually declared that would help us with that? Test. Yep. So what's next? This is supposed to be easy. This is the easy part.
If test is less than or equal to 100.
Less than or equal to 100? Are you sure? Oh yeah, absolutely. Sorry. I even got, yeah, definitely. Less than or equal to 100, yes.
Yeah. See out.
See out.
What they asked us, I don't know.
They asked us to print out yes or no.
Okay, so yes.
So see out, yes, absolutely. And what if it wasn't, what if test was actually greater than 100? What are we supposed to tell the user?
No.
Else. There you have it. We just basically solved the whole entire question.
I have a question.
Yes, go for it.
Okay, now we said if test is less than or equal to 100, can we, are we supposed to put also greater than or equal to 0? Because it seems logical this way. You know, sometimes someone might press the negative sign by mistake or something. So this would be something not realistic to have a negative number of hamburgers.
So that's a very valid point. But here's the thing with code forces. They always give you the range. So we have to assume that the user is entering correct values. But that's a very, very good point. So when you're actually writing your own program, you have to put into account all these different possibilities and all these different mistakes. However, here in code forces, they really make it easier for us and they just set the range and they tell us to assume that the user to enter correct values. And here it's telling us that the value is from, the value can be from 0 up to 10 to the power of 5. However, when you're writing your own program, it's always advised that you put into account all these different possibilities. So yes, that's very, very valid. But for now, we are not going to be putting into account these things because we weren't really asked for that. Is it clear? Did I answer your question?
Yes, thank you.
Awesome. So since we have just 3 minutes, let's just try and copy the input. So this is a sample input and we're gonna just simply copy and paste it over here. So all we did is declare integer n, which is gonna be used for the range in the for loop. And we declared another variable that we will be asking the user to enter 3 times, since here we have 3 as a range. And the code will execute according to the if and else statement over here. Oh, so okay, so here's the thing. ID1 sometimes causes some trouble, and I had the ID1 tab opened a long time ago, so it completely erased our code, and that sometimes happens. Sometimes you have to deal with these things. So we have 2 minutes left. I think we can write the code all over again. Unfortunately, it's how things are, but that's fine. So basically I had to open the tab earlier and not wait that long to execute the code. Anyway, so I'm just basically repeating the code all over again. And all we have to do is see in test every time. And if we said if test is less than or equal to 100, see out yes. And if it isn't, else see out. So I'm convenient about that inconvenience. Next time, I'll make sure to copy the code just in case. So let's just try and run our code and see what it gives us. So it's supposed to give us yes, no, and yes. So in order for us to test the code, all we have to do, I could have copied it, but that's fine. All we have to do is copy it again just to check. And we can go to code forces and test the code here, submit code. I'm gonna let you girls know about how you can create your own account and all of that in the email today, in the email I'm gonna be sending today. And all we have to do is submit, and our code is accepted. So our code is correct for hamburgers. I'm so sorry, there's only 1 minute left. I really wanted us to solve another question, but that's totally fine. We can solve it next time. And please check your emails today. I'm also going to remind you on WhatsApp because I'm going to be sending you some practice questions that you can do. And I would love to see your solutions to these practice questions. So if you have any questions before we end today's session, please feel free to ask. And I'm going to stop recording. So I'm going to stop my screen.